Okay, I think this is recording. Yes, okay. Just wanted to check. I wanted to post this video just to kind of help some of you out if you're struggling with these questions involving probability. These were ones from last week. And these are a bit challenging. The challenging part is interpreting the information they're giving us and to take that and put it into a table. So I'm going to just go through one of these problems with you and kind of maybe help break down some of the tricky parts for this. Okay, so with that said, I'm going to switch screens here. So I'm going to stop sharing. And now I'm going to share this screen. Okay, so I think that's working. Yes. All right, so actually, I forgot to look at the problem. So I'm going to pause the recording here. Actually, can't do that. Let's see. Is that that? No. Stop sharing, and then let me go back to that problem. Okay, so sorry about that. We had to take a little break there, but now you should see the problem here. I just wrote it out. Had to get it transferred one way or another, but now you all see it. So the question is, if a disease has an incident rate of 1% or 0.1%, notice that this is equal in decimal to 0.001. So it's literally 0.1%. And a false negative is 7%, and false positive rate is 4%. Compute the probability that a person who tests positive actually has the disease. So a couple things I want you to notice in here is that the way, first of all, the probability they're asking us to find is worded. It's actually a conditional probability, not just a regular probability. The condition is that the person tested positive. Compute the probability that a person who tests positive actually has a disease. So the assumption going into this is that they've already tested positive. So you went to go get tested for coronavirus, let's just say, and you got a positive result. What the question is asking here is, after you have received that positive result, so that's already happened, what would be the probability you would actually have this disease? Okay, not to put it into terms better, but it is relevant right now, I suppose. So this is coming with a condition. I'm going to use I for infected. So the probability you actually have the disease, that you're infected, given that you've already tested positive. Okay. So this is a bit of a tricky thing. And so what we want to do is to create a table. And there's another video that shows us this as well. But there's a couple other things I wanted to bring out here. So on the left-hand column, I'm going to do infected, not infected, so I and not I. And of course, we always want to include our totals. And then across the top here, we're going to do your testing status. So you got a positive, or you tested negative. And then, of course, we have our totals here as well. Okay, now, I want to break down the boxes here, first of all. So I'm going to use a different color here. But when we talk about this box here, so this has the I, so you have the infection and you tested positive. This means that you tested positive and you are infected. So this is kind of this would be the success box, right? As far as testing goes. We hope that when we test someone that the positive results will match up with those who actually have the disease or actually are infected. And so when we go to the blue one, or to the next one to the right here, I'm going to put this in blue. This is, you have the infection, right? So it's in the column for you have the infection, but you got a negative when you test it. Okay. Well, if you have the infection and you tested negative, then the test failed, right? You actually do have the disease, but now you're being led to think that you don't because you got a negative result. And so we call this a false negative, okay? You got a negative result, but it's a false negative because you actually do have the disease. All right, now, if you don't have the disease, right, not I, then what do we want? Well, if our tests are working properly, we should get a negative result. So this is also a success box in that the people who are not infected, actually the test worked because their test came back negative. Next to it, here we have our other sort of bad outcome, where we don't have the disease, right? It's in the not I row, but we tested positive. This is called a false positive, right? So the blues indicate kind of a failure, and the greens indicate success, okay? So, and it's important to be able to identify those things. Now you'll see in the video also that, and this may have confused some of you, like, well, why are they just picking this 10,000 number? The fact of the matter is they just pick a big number so that we can avoid working with decimals, really is why they did it. And so you could pick 10,000, 100,000, even 1,000 would probably work for most of these. But I'm just going to stick with what they use, which is the 10,000. We're just going to assume we have a population of 10,000. And that way, when we put numbers in here, we're actually dealing with counts instead of percentages. It's going to be easier for you guys to kind of see what we're doing if you're looking at it as counts. You'll just understand it a little bit better. All right. So with this total of 10,000 population, we want to first start off putting out, if I had a population of 10,000, and this was my rate of infection up here, the 0.1%, how many within this 10,000 would actually have the infection and how many would not, right? Here we want to put what the total actual infections are. So the way we do that is by taking the rate of infection, which is 0.001, and multiplying it by the 10,000. In other words, let's find out what 0.1% out of 10,000 would be. And so that is going to come out to, well, where's my calculator? It's actually going to come out to 10. So in other words, 10 people out of 10,000 at a 0.1% would have the disease. And then that means the other, if I subtract from 10,000, 9,990 people out of that 10,000 would not have the infection. Okay, so this is, I want to get those laid out first. So that's kind of our first step. All right, the second part says the false negative rate is 7%. So where would false negative rate be? Well, in the negative column, remember, blue is kind of the failure and green is kind of the success. A false negative is this box here, where it's under negative, but you wouldn't want to test negative if you actually had the infection, right? So that would be a false negative. So with a 7% false negative, I want to figure out what 7% of 10 is. So we can actually do that. We're going to go 0.07, which is 7%, times 10, which actually is going to give me a decimal, 0.7. which I don't like, but that's what we were trying to avoid. Now, if we had gone with 100,000, I would have had 7 here instead. See, so that's why we tend to do those. So if this is 0.7, then this would be 9.3 here, because this box plus that one should add up to the 10. Okay. And then the second clue they give us here is that the false positive rate is 4%. Well, false positive would be this other blue box. We tested positive, but we're not infected. Now, the only way I could get a false positive is if I'm someone who doesn't have the disease. Oops, what's happening? Right? And the people who don't have the disease are here. So the reason I use 10 up here, let me go back to that, is because the only way I can get a false positive is if I actually have the disease, right? And there's only 10 people that do, and I test negative, which was this box. And we said it was a 7% chance. So that's why we had to take it out of 10. And here also, the idea is the only way I could get a false positive is if I don't have the disease, but then I test positive. And that's a 4%. So we're going to take 4%, so 0.04 times 9,990. So again, this does give me a decimal, so I'm going to use that, but 399.6. So almost 400 people would test positive. So they go in to get their test, and they're like, yep, you have the disease, but in reality, they don't. That's kind of scary, isn't it? Like 400 would do that. So, and then if we subtract 399.6 from 9,990, we have the other number here, which is 9,590.4 that don't have the disease and will get the proper results back, which is a negative result. All right, if we add these going down, we want to get the totals for these columns as well. So this would be 408.9, I believe is correct. Let me just double check that. Yep. And then adding it over here, we're going to get 0.1 and then 1959. So that should be right as well. Okay, and those two together should give me 10,000, and they do. So we know we have our boxes right. So then what do we need for this conditional probability? So the given part of this, right, which is this up and down line. This up and down line reads given. What I want to do to find this is to find the box that is both I and positive, and then whatever your condition is, that's the number that goes down here. How many were positive? And in this case, if we look at our table, the positive column is this column. The total number of people who tested positive is this 408.9. So that's our assuming. Since we're assuming you tested positive, our denominator is going to be the total positives. So to find my probability, the probability I actually have the infection, assuming that I've already tested positive, will on the top be where the I and positives meet. I am positive is this box here, I and positive. So I have 9.3. There's going to be 9.3 people who test positive and have the disease out of the total number of people who tested positive, which is 408.9. So that's 0.0227. which is 2.27%. And I want you to think of the implications of that. Let's say you actually do go in to get a test. And the false positive rate is only 4%, right? Well, that doesn't seem like much, and it's not. It's a very small number, false positives. But 4% out of a large number, which in the case of most diseases, the large number here is the people who don't have the infection. Most people don't have the infection in this population. And so, since we're taking 4% of this larger number, we actually get a very big number here, okay, of false positives. So if you go in and get a test and it comes back positive, you always want to do it again. You want to double check, because the probability you actually have the disease is really low. And that's what this conditional probability is calculating for us. If you've already tested positive, what's the probability you actually have the infection? It's less than 3% chance that you actually have the infection. And that's why most of the time you always want to get a second opinion, or you want to do a second test, because depending on the false positive rate, even 4 is a pretty low one. It could still mean that you don't have the infection. Okay, and you're just getting a false positive back. Anyway, I hope that helps maybe explain and kind of break down some of the mystery surrounding these particular probability questions.